Hey everyone, and welcome to this my video on when is a function differentiable? God, long title. Now, my name is Darren from Maffs Guru, that little corner of my interweb where basically there are all these videos, downloadable resources, VCAR exam questions, and so much more. So head over there, absolutely free to sign up. And basically everything I'm about to write on behind me, you can download as well. Now, what are my learning objectives? Well, basically to know at what points a function can be differentiated. And you may be thinking, well, surely all of them, yes? Well, if we go back to the very beginning, and I don't mean the Big Bang very beginning, I'm talking about the idea of the beginning of differentiation. We talked about differentiating from first principles, and then we looked at the rules of how to differentiate with positive powers and negative powers and what it meant. And through all of this, we needed to make sure that we were really finding the value of the gradient of the tangent at a particular point. Now, obviously, when we did differentiation by first principles, we looked at a point and we drew secants and we got closer and closer and closer. And we found out that those secants effectively became the gradient as the value of h became smaller and smaller and smaller. And you're probably turning around saying, oh, hold on a moment, that was limits. Absolutely. And yes, I've uploaded yesterday a video on limits and continuity, which is probably a little bit useful for this one here. But the idea is, can every single graph have a gradient taken at a point? Can you think of ways where maybe there are points on a graph that can't be? And that's pretty much what we're going to do here. Now, first things first, this isn't really in the course anymore, at least, the idea of what a modulus function is, but this is basically the graph of y is equal the modulus of x. And what that really does is take every negative part of a graph, everything that goes sort of below the x-axis and reflect it up to the y-axis. So realistically speaking, if you look at this graph here, it actually was the graph of y equals x. But by taking the modulus, we effectively ended up with this bit here. Now, to be able to write this, we can use a hybrid function. And lo and behold, here is my hybrid function. And what do we get? Well, we get the idea that my function is split up into two distinct sections. There's this here that has the function minus x for all values where x is less than 0. And it's got a value of y equals x for all values of x greater than and inclusive of 0. Now, if we actually look at this here and we go back to what we were talking about earlier, is this graph continuous? Absolutely, it's continuous because there are no dots floating above somewhere. There's no open circles anywhere because for all intents and purposes, this graph here at the point where there is a kink, and we'll use the idea here that this graph now has a kink. If I put 0 into here, I get minus 0, which is 0. If I put 0 into here, I get 0. So that graph will join and meet. The thing is, it doesn't seem to meet very smoothly, does it? Okay, so here's my question. What happens when we look at the gradient of each of these lines? Now, if we look at this line between here, and we're going to say all the way down here to that very end point here, and endpoints become important, what is the gradient? Well, that's basically the line y equals minus x. The minus is basically minus 1. So we know that for this part here, the gradient of that is negative 1. And the gradient of this section here must be 1, yes? But the big point is, what on earth is the gradient at that point there? Well, I have an idea. Let's draw a graph of my individual gradients. So I'm going to draw a straight line here. I'm going to draw a straight line here. All right, so, oh, interesting. My inequalities have changed. I wonder why. So what I'm going to do now is for x values less than 0, it's going to be negative 1. So there we go. So there's negative 1. For, oh, hold on. For greater than 0, it's positive 1. And what do we notice? Now, if we go back to our limit stuff previously where we were looking at saying, well, hold on, is that graph continuous or does it have some sort of discontinuity? There is now a massive discontinuity here because there is no way at one tiny point here, I can suddenly go from a negative 1 gradient to a positive 1 gradient. So now I have to put open circles here and here, which now hopefully goes to explain why that inequality has changed. No longer is it greater than or equal to, or in fact less than or equal to. It doesn't seem to include the value of 0. All right, now, go back to differentiation from first principles, and let's turn around and say, okay, to find the gradient between any 2 points, what did we do? Well, if we wanted to find the gradient at this point here, we'd choose points, and we'd get closer and closer and closer, drawing secants.